Welcome to the Ultimate Competitive Programming Roadmap. Yes, all of this image, it's all true. Though actually I think roadmaps are kind of a scam. They offer the promise of a one-size-fits-all guide, when that kind of just can't exist because everyone has different styles and issues that the guides just can't cover everything about. And also the underlying issue or thing you're missing probably isn't that you're practicing the wrong problems or topics, it's that you're practicing the wrong way. See the advice section of this video for more. But I'm giving you a roadmap anyway because it'll get views. Enjoy. But it's also not a get-rich-quick video. Those don't exist. You are going to have to put the work in, and all I can do is help you not be misled along the way. And the advice is going to be genuine. It's going to be a real roadmap, both the advice section in the video and the roadmap part itself. So don't let the tone of this video, where I'm being sort of sarcastic about the whole thing, take away from the actual advice that's going to be given. There's definitely advice in this video that will transcend every roadmap that has ever existed. Probably, I guess. So stick around for it. In essence, this video is designed as a guide for learning competitive programming, such as how to choose problems for practice and which topics are useful to learn, and a bunch of other things. And it's especially cool for a few reasons. For one, it covers all the way up to the Grandmaster level on code forces, which is huge. Not many roadmaps do that. On CodeChef, that's the equivalent of 7-star. In the context of interviews, at that level you can absolutely dominate basically any interview question. You don't need to get that far. I would say Candidate Master is a safe bet for mastering interviews, but do whatever you want. And second, the advice is specific. It's not blanket advice. There's a different strategy for every rating range because everyone is a bit different. So you'll get a strategy suited directly for you. And third, there are a lot of opinions involved. I asked a bunch of questions to everyone, or to people who have succeeded before, and got roughly 150 distinct responses, so you're going to get real strategies that actually worked for people, along with my own advice. And by the way, to everyone who filled out the form, thank you. I read basically every part of every response, and there was quite a lot that I never even considered thinking of, honestly. So a lot of stuff in this video is inspired directly by stuff from the form. So how does this video work? In the description, you'll find some timestamps. The timestamps that are marked important are, well, important. And they represent the absolutely vital parts of this video that you should definitely watch. This video is organized in a bunch of disjoint sections, which you can navigate using the timestamps. If you expected something coherent, sorry, that's not how this channel works. But it does mean you can watch only the parts you're interested in, which is nice, especially because this video is so long. If you want a list of the sections, it's right there in the timestamps. I'll give you my thoughts on each part and how much they're worth watching. The first bit is this intro. It's self-referential. That's kind of cool, huh? In fact, this is technically a roadmap of the whole roadmap, this table of contents, so that's also pretty self-referential. And anyway, the next bit is a section with general advice. I think it's an absolutely essential part of the video, and it has some stuff I don't think I've ever mentioned before. Seriously, if you're only going to watch one part of this video, choose the advice section. It should be really, really helpful, particularly for beginners. Then there are some common mistakes that should be avoided, which is similar to advice, I guess, but I'm treating them separately anyway. Then there's the general practice advice. It's basically some advice on where to get problems on and what to do when practicing on a particular problem. And then there's the rating-based advice. As the name would suggest, this is advice based on the requirements to pass through a specific rating. It has a bunch of things for each rating range, like topics that are helpful, a general practice strategy, and a kind of benchmark for the level you should be at to be able to reach the next rating mark. While I of course recommend watching the part for your rating range, you can also look at the nearby ranges too, because there's probably some advice that can carry over. Though there will also be some repeated stuff across the sections. It's probably not a glitch in the matrix. Probably. Finally, there's the conclusion, which wraps up the biggest points that I want to make throughout the video. I think the general advice section and the conclusion are both very worth watching, particularly for people who are near beginner level. Now, if you don't know me, you could ask why I'm qualified to give this kind of advice. And the answer is, I've done all of it. My rank on Codeforces is International Grandmaster, which is one above Grandmaster, and my equivalent rank on CodeChef is 7-star, which is as high as it gets. I say this not to flex, because I don't want to do that, but just to say that I mostly know what I'm talking about, I guess. All I'm trying to say is, you're in good hands with this video. Okay, before we start with actual advice, I want to do a section on why I don't believe in the roadmap part of this video. But it's also advice, so you should probably hear it if you do believe that the roadmap part of this video is going to change your life. But I clicked on this to see a roadmap. Why do you hate your own video? Someone may ask. And well, the roadmap is a good magnet for viewers because a lot of people want all of the work to be done by someone else and will happily accept something like this. And I'm trying to send a very important message with this video, and you can't send an effective message if nobody's going to listen to it. But really, there's no ideal path to learning stuff. There's no optimal order to learn stuff in, and there's no optimal set of problems to solve. You can ask 100 Grandmasters the same question, and you'll get almost 100 different answers. And that's because everyone had a different experience that worked for them. My experience, this video is going to be one opinion. There are going to be other opinions that are probably going to work, but this worked for me. So I can give you something in this video and say that it's what worked for a bunch of other people. It might work for you too. Some other strategy can work just as well. There are probably dozens of roadmaps on the internet that say totally different things, and most of them have worked all the same. Basically anything will work, I would say, as long as you're truly challenging yourself. But let me emphasize this. This is really important. No roadmap will work for you if you aren't practicing individual problems correctly. In the majority of cases, the issue is that you're practicing just for the sake of marking off problems as solved instead of really trying to learn from them. Things like daily routines and stuff like that can sort of force you to try to hit a certain mark every day, and then you're practicing just to meet that mark instead of actually practicing to learn. More on that in the next section, which will happen right now. This is the biggest takeaway from this video, by far. Not any of the practice strategy stuff, just this. I'm offering you a perspective shift in what you should be trying to get out of your practice. You can accept it or not, but if you want to improve, and especially if you're currently stuck, it's the best advice I can give you. So first, remember that you aren't practicing to find out the solution to some problem or prove that you're capable of solving the problem. You're practicing to get better at solving. Understand not only the solution, but also how you can come up with it later on. Understand how the editorial came up with it. If it's a very common idea, also make sure you won't miss that idea in the future. But you usually won't get far by just memorizing solutions. You can know the angles to look at a problem with. You can memorize those, that's fine. And the questions to ask yourself about a problem that lead you to certain observations, such as first trying simplifications of a problem. But you can't memorize particular solutions and hope they'll show up later. The particular solutions that you're expected to know fairly well are called algorithms and data structures, and there aren't that many important ones. Also, spending a small amount of time on each problem will mean you get very little out of that problem. It's just not enough time when you need to be immersing yourself into the harder problems. That's where real creative thought will happen. When you've tried all the obvious stuff and you have no immediate options left for a problem, you have to take the time to actually train your brain, and you do that by thinking your way through the times where you don't have ideas. The immersion and deep thought are the main way that you really improve. Practice to maximize that. And again, remember that your goal is to be able to come up with this stuff, not just to know it. Along with that, be wary of stuff like hindsight bias, and if you have to give up, make sure you're really absorbing the thought process and the way you can think to come up with ideas instead of just memorizing them. A lot of people don't like the idea of spending very long times on problems, like many hours or even days, but I think it's effective because, for one, it worked for me, and also it forces you to exhaust every possible solution that you can think of. Only when you've tried something you already know how to do can you start to figure out things that you don't know how to do. You're kind of putting your mind in jail and telling it to figure out a new way to get out. It has no option but to think of new ideas. And while all that's happening, you're constantly exercising your creativity muscle the whole time. No, not just that. You're giving it a full multi-day long workout. Similar to how exercise is most effective when you have to really push through fatigue, practice is most effective when you have to push through being stuck. And your brain's going to need some pretty strong muscles to be able to punch through walls. I'm getting pretty lost in this analogy, but the main point should be clear. The goal is to practice thinking of things that you aren't already familiar with, because that's what observations and ad hoc problems need you to be able to do. And if after all that time you still decide to give up, you know that you're going to learn something new from the solution, because you spent so much time on it and you tried everything you can possibly think of. There's some scientific basis to all of this too. We humans learn from challenges. We adapt. You have to convince your brain that solving this problem is the most important thing it needs to be doing right now, maybe apart from breathing or something. You're welcome for making me think about breathing, by the way. And if you convince your brain of that all the time, then it has no choice but to get better at problem solving. And to do that, all you can do is spend time trying. Just trying. You don't even have to be successful. Just try, and your brain will figure out new and creative ways out of jail. There's a blog about practice by a legendary Grandmaster. I'll link it. It says that a lot of high-rated people have a whole part of their brain dedicated to this stuff, where they're able to passively think about problems and just like to spend time thinking about them, at random times, like while showering or skydiving. You develop that, again, by convincing your brain that this stuff is important, and that you need that section of your brain. This also assumes that you're practicing on problems that are fairly difficult for you. Don't lie to yourself by solving problems that are too easy, and don't challenge you, because that ruins the whole point. Another thing, if you don't already, you should question as much as possible. Ask why about everything. Why are we doing this? Why is this correct? What do we need this information for? Why am I watching this video? What do I expect to get out of this? That type of thing. Your ultimate goal for learning something is to understand it in a way that totally makes sense to you. And that means digesting every part of it and breaking it into pieces that fit your intuition. If something doesn't make sense, ask yourself what the point of it is, and figuring that out will help it make sense in the big picture. A good benchmark for having learned something is to be able to explain it to someone else. Actually, in part, that's what this YouTube is for. Because I often end up thinking of simpler solutions when I'm explaining a solution and when I've broken it down part by part to explain it in a solution video. How do you do this? Let yourself do the solving. Reading the editorial or asking for help too early is allowing someone else to do the thinking for you. And unless you're getting hints and still personally really involved in figuring out the solution, that will be rather unhelpful. And even then, hints have limited effectiveness. When I try to learn something, I fill in as many gaps by myself as possible, especially for conceptually simple concepts. For every tutorial I write, I always start by coding the entire thing by myself without referencing everything else. That proves to myself that I know the details and I understand every aspect of the concept well enough to write a working program with it. A good example of where this works is binary search. You can learn the conceptual idea pretty quickly. You have some range, and you keep cutting it in half until it's small enough. But then you get to coding it, and you realize that it can be really confusing, and there are a crap ton of off by one errors that you encounter, and it can be a mess. So instead of trying to absorb someone else's code, take the time to try to figure it out for yourself. The plus ones and minus ones and stuff will make a lot more sense when you fully modeled it in your own head, and you'll understand the whole thing better if you're able to code it without needing to consult anything. And on a related note, I genuinely hate reading editorials. I also hate asking for help. For one, I see it as admitting defeat to the problem. When reading an editorial, you have to again do this conversion process where you try to understand the words in your own terms, their words in your own terms. Then you have to figure out what you missed and why you didn't come up with the solution. And you also run the risk of understanding the solution just to know the solution instead of using it to learn some new thought process that you missed, and so on. That's in part why I've recommended spending long periods on single problems if you aren't completely stuck, to avoid the tediousness of having to process an editorial. So overall, if you find that you aren't understanding things, you just might not be doing enough work on your end. Consider that. I also did basically all of my practice without anyone to help me. I had Yusuko and Yusuko training, which was a set of problems, and that's it. When I was stuck, there was nothing but my own brain to turn to. I think it helped a lot, and I think many people are too used to having someone else to settle any issues they have. Instead, I had to think through any misunderstandings I had by myself, and because I did that, I understood a lot of things very intuitively because all of the reasoning was my own. I bet many of you would benefit from such stuff too. In fact, I have a radical recommendation that you may want to try. Go some period of time, say a month, without asking anyone for help. You can still read editorials if you're totally stuck and you don't ever want to try the problem in the future, but other than that, all of the thinking should be yours. If you're stuck on something, figure it out for yourself. I think that you'll end up understanding a lot of things way more deeply by doing that. And on top of that, you'll just get more out of solving problems. Because say you do a problem, get stuck on it, give up, and ask someone else how to do it. And they tell you how to do it. So now you know how to do it. And what else did you get out of that? Nothing, because you were just told the solution. You can say that you might get hints and have some of the effort be yours, but you're still just borrowing someone else's thought process instead of working one out for yourself. You're getting very little out of it. It's just too easy to ask for help and have someone work out your thoughts for you. So try for a while to just not do it at all. There's a blog post on Codeforces that covers a similar topic but explains it in a different way, and I've put that in the description if you want to find out more about it and why it's so common. The author's take on it is that having the editorial kind of acts as a mental safety net, where you can maybe be taking problems less seriously because you have a timer or because the solution is so easy to access. And so you don't get much out of any problem, and you don't get much out of practice when you're stuck in that mindset. Now, throughout the roadmap, there will be other strategies that other people used, doing things like reading the editorial after X minutes of being stuck, and that kind of thing. Even one of my own past videos has recommended this, though that 90-second video doesn't mention my strategy when I initially started competitive programming. It's sort of my later strategy. Anyway, this can have some advantages over solving for a long time, such as getting diversity in problems and coming across a lot of different techniques. But it's also very contradictory to some of the other advice I'm given and the advice I'm going to give. But the reason that there are a lot of different strategies, I mentioned this before, is because a lot of things work. Like, I have stuff that worked for me. I have multiple strategies that are totally different, but they both work for me. And other people have stuff that work for them, and they're different, but they all work. The main thing, again, as I mentioned before, is just that you have to be really trying each problem out. Treat your brain like a big muscle that you have to exercise with to make it stronger. That should be your mindset when you're solving problems. As long as you're absolutely sure that you're exercising your thought process, the amount of time you spend isn't so important, as long as it's, not like a minute a day or something. On the note of mindset, consider how much time you might spend searching for the optimal practice strategy or the best permutation of topics to learn, etc. I know that many people will spend a lot of time on it. If it's anything more than a day, or even just a couple hours to figure this stuff out, that's a lot of time being spent on something that isn't practicing, especially for the topic part of it. It's mostly okay to learn topics in any order. If something doesn't make sense and there are prerequisites like a different topic, then that will be obvious, and you'll be able to find the prerequisite and study that first. I've also noticed that people spend so much time on other things too. For example, stuff like which IDE to use, and it's framed like which one is best to do competitive programming with. And I mean, do what you like to. If you're an IDE fanatic, don't let me stop you. But if your goal is to improve, then worrying about stuff like that, especially the best one for competitive programming, is completely overthinking it. The best IDE is the one you're most comfortable with. Your coding speed won't come down to whether you're using Vim or Notepad++. It'll come down to how fast your brain is. But if you're still stuck with doubts about where to start or what you should be doing, fine. That's kind of what this video is for. A complete and final guide to cover every possible issue you could have with starting to practice. Once you're through with this, you should really stop looking at videos like this and just jump into it, jump into practice. As you get better, you will get to understand your learning style and figure out what will work best for you. But especially when starting out, just pick something and try it for a while. If you don't like it, try something else. A lot of things will work. Seriously, just go solve some problems. These strategies have worked for other people, the ones I'm going to mention in this video. You can believe in them for yourself too. As long as you're actually learning from the problems you're doing and they aren't too easy, it doesn't matter too much which ones you're doing. There's a bit to say about motivation too. Many of the people who have stellar rating graphs and those huge success stories have had the most powerful form of motivation on their side, which is just that they enjoy this stuff. Because your brain will naturally pick up stuff easier and you'll want to do it more, and it'll just be easier to learn anything if you already like it. Granted, nothing's guaranteed, enjoyment won't get you far alone, and you can still get decently far even if you don't like it. But if you don't even like it, it's just going to be harder. Expect that. Expect it to be harder, and don't be surprised by it. Whatever reason you have to be doing this stuff, you're going to have to stick close to it. And by design, it's not easy to get good at this, and it'll take a while. That's natural. Day-to-day progress is too slow to notice, but if you see yourself being visibly better than, say, yourself a year ago, that's progress. And on a related note, don't get lost in comparisons. They aren't good for you. Your journey is your own, so own it. If someone is improving better than you, and there will be that someone, there is always that someone, so be it. Just learn from them, and grind hard enough that you start to outpace them. I don't know who I'm actually telling this to, but I don't know, maybe it'll help someone. A while ago, I gave some advice about optimizing stuff like sleep and external factors of your life that hinder your focus, and I claimed that it improved my performance on contests and it can do the same for you. I want to make sure I'm not misunderstood here, so I just want to say, your performance is roughly a function of your skill. So if you improve your skill, you'll be basically guaranteed to improve your average performance. Other things like sleep and arguably your ability to implement stuff like turn it into code will help you get a better performance for a particular skill. That is, you will have a better chance of outperforming your skill than doing much worse than your skill. So you might get a small boost from it because it's helping you meet your full potential. But these things don't change your skill. In the long term, the only way to improve is to improve your skill. I just want to make that clear that nothing is a substitute for practice. Granted, sleeping well can probably make your practice better too. Another thing, it can be helpful to organize the problems and contests you do so you can easily refer to them later. Especially for mistakes that were made, and you can also easier highlight the areas you have issues with. I asked about this on the forum, and sort of as expected, the vast majority of people didn't do any of this in any way, shape, or form. Though that doesn't necessarily mean that doing it is counterproductive, it just means that you'll be fine if you don't. But if you do happen to like to be organized, you can keep track of your past problems or contests and some information about them. This can be as simple as a spreadsheet. I've already made a video that involves doing this and why it's helpful. You can check that out from the description. On the topic of motivation, I've made another few videos in the past about it. One involves how to deal with bad contests and huge failure, and the other focuses on feelings of inadequacy and the struggle that a lot of people, including myself, have experienced, whether successful or not. Both of those videos will be in the description. In general, it's hard to create the logic or the solution to a problem. The main way to get better at this is to practice, as improving your thinking ability will help you in absolutely everything. Knowing a ton of stuff will not help you if you can't figure out the backbone of the solution, or how to reduce the problem to stuff you know. You have to develop a thought process, typically by learning from solution patterns of problems you encounter, or just adapting your brain to better process these kinds of problems. But I also know of at least a couple of resources that can help with the more conscious parts of that too. In particular, I've made a video on a partial strategy to approach a problem. It doesn't cover everything, and it isn't the ultimate solution to everything, because everything still mainly stems from your ability to think and reason, but it can help you rule out some simple stuff and make sure you've exhausted most of the possible solution ideas that you know of. And another thing is a blog from a high-rated contributor about how to solve ad hoc problems, which are problems that don't use any particular technique and can be kind of abstract. I think it's very useful to learn the common ideas that show up because they can help out in many of the problems. Again, both of these are in the description. Beyond that, I've also just put a bunch of other general resources in the description. You should check them out if you're interested to see what can help you. This list will probably be updated every so often too, and feel free to suggest anything if you think you have something that'll be useful to add. Okay, now for general advice. This will be in semi-list format, but each item will have details to it. Number 1, find some friends, maybe around your level to help with like motivation and stuff. Or maybe some smarter friends to talk with and learn from. And furthering that, it can help to join a dedicated community too. But as I mentioned before, don't become over-reliant on asking people for help or just talking to people. It's nice to hear some ideas that you've never seen before or cool insights into things you thought you fully understood, but don't pass on your task of learning to them. Number 2, your rating is solely limited by your skill. If you want to get some certain rating, the best thing you can be focused on is improving that skill rather than short-term results. Get the skill and the rating will follow. And following that, contests are super important to get the experience of a stressful environment, and you should do them for their value instead of fearing a temporary rating loss. Also, remember to have fun. It can be hard to do that sometimes. Yeah. Number 3, remember that the goal isn't to make programming a chore and that you don't have to go full force all the time. You can take breaks, even for more than short periods of time, and you won't be too far behind when you come back. Definitely don't force yourself to do competitive programming when you don't want to. You will get very little out of that improvement-wise. If you feel particularly burnt out, some say it helps to reflect on why you're really doing this and if it's worth it. Number 4, a lot of training can help you with confidence in your abilities, especially with specific topics, and confidence is good for everything. I personally don't believe that there's anyone who doesn't have what it takes. Sure, intelligence and stuff will help certain people grow faster than others, but if someone is really stagnating, chances are there's a huge flaw in their way of training. You have the ability to improve. It also helps to focus on what you're already able to do instead of dwelling on what you can't yet, if you need motivation for, the progress you've made and stuff. Number 5, upsolving is important, as in solving problems that you couldn't solve during a contest. This is in part because these problems highlight weaknesses that you have since you weren't able to solve them, and upsolving will help you find and destroy those weaknesses. Number 6, don't guess problems or ideas when practicing, or if you do, take time to try and prove them. Again, the point is to improve, not just get a problem accepted. And here are some mistakes, from both my own experience and the forum, that you should avoid. I have tried my best to make this disjoint from the previous section on advice from the forum. Note that in most cases, I'm explicitly saying what you should do to avoid the mistake instead of saying the mistake itself, but you can use the text to clarify what the mistake is. Also, these are not in order of importance because otherwise you would have an incentive to skip some part of the video, and I can't let that happen now, can I? It's also in list form. Number 1, the biggest mistake is to solve problems without really learning from them. For example, by spending too little time on it, or by delegating the thinking part to someone else. See the learning mindset part on the advice section and the conclusion for more on this if you haven't. Number 2, another thing. People will probably disagree with me on this one, but I'm going to propose it anyway. If your goal is long-term improvement, you shouldn't care too much about your speed on problems. Solve count divides the scoreboard into brackets. There's a bracket for 0 solves, one for 1 solve, one for 2 solves, one for 3 solves, etc. The faster you are, the higher up you'll be in your bracket. But unless your goal is close enough that being high in your bracket is good enough, then it doesn't matter how good you are in your bracket. Because as I've said many times, temporary rating changes matter very little. Your goal is to move up to a higher bracket, not move up in your bracket. And sure, there are some contests where speed is super important and most people have the same solve count. So what? They're outliers. The rating system is designed to ignore outliers in the long term, so you should focus on the average contest, which is going to be broken up by brackets. And ultimately, your goal is really to move into the next bracket. If you're consistently in a higher bracket, you will consistently perform better, and it won't matter how fast you were, say, a few months or a year ago. So just be fast enough to solve all the problems that you're capable of doing. Other than that, speed is much less important than being able to solve harder problems. Practice with that goal in mind. Number 3, when doing a problem, sometimes a particular idea is just a dead end and there's no solution hiding anywhere in it. At a certain point, you have to be able to drop it and not be super stuck on a single idea. Number 4, people have recommended skipping the problem you're on in a contest if you've been trying it for way too long. I tend to do this myself if I get really stuck, but it usually doesn't end well for me. It's pretty psychologically hard to move on to a problem that will probably be harder than the one you were just stuck on, knowing well that you're already behind in score from where you should be. But if it works for you, try it. Number 5, don't let yourself get away with glaring weaknesses, or even the non-glaring ones. Just look for your weaknesses and work on them instead of making excuses. This goes for both topics that you're bad at and stuff like bad habits. Number 6, people say being consistent with stuff like practice is important. I was extremely inconsistent in my time practicing, but I still made it work. For some people, it may still help you though. Number 7, don't click off this video. At least yet. Actual number 7. Don't jump immediately into writing code, especially if you haven't fully developed your idea yet and you're still thinking about how the solution will work as you're writing it. Especially if you aren't that confident in the idea and it has a strong chance of being wrong. Also, especially for stuff like math, where it makes a lot more sense to brain out the formulas on paper. Another case is don't immediately start coding an idea that you know is complicated. You might instead try spending a bit more time looking for a simpler idea, and often it will work. I personally make both of these mistakes way too often on, say, Div 3s, and I jump too quickly into wrong or overcomplicated ideas. People find that it helps to visually organize their ideas, say like on paper or on a whiteboard. If you don't usually do this, it could help to give it a try. Number 8, take the time to look for edge cases. That's it. Number 9, probably try not to misread problems or look in important details carefully, especially if you have a history of misreading. I have personally misread like 3 different parts of a single problem and was stuck solving something like vastly different from what the actual problem was. Number 10, a lot of people say that a common mistake is forgetting to read input in problems. I guess I've done this too, but maybe it's not worth an entry on a list like this. Whatever. This video is already too long. I guess it can't hurt to have more stuff. Number 11, and when debugging, don't assume any part of your solution is right, unless it's been rigorously tested before. For example, if you copy-pasted your segment tree template that you used to solve some other problems before, you can probably trust it well enough. But if you rewrote that segment tree, you better check it for bugs, because it could very well be the issue. This also goes for ideas and especially any assumptions you've made. Debug both your code and your idea and don't rule anything out as a possible issue. This happens so often when people spend a lot of time doubting their big picture idea and it turns out they just had some overflow somewhere or some mental typo like forgetting to multiply by 2. Number 12, there's a psychological balance you have to find in terms of looking at the standings or on sites that have them, the dashboard, to see your ranking or how many people have solved each problem. To some people, it's motivating to see that you're doing well or that your friends have managed to solve some problem and so you should be able to do so as well. And to others, it can psych you out, and you'll become overly concerned about performance and lose your focus. Figure out which type of person you are and control your temptations accordingly. Don't do it if it's going to hurt you. Number 13, speaking of psychology, don't sell yourself short on problems that you haven't even really thought about yet. If you know you're weak in some topic, for example, it doesn't mean that you can't solve a single problem involving that topic. If you give the problem an honest attempt, you'll probably find more success than you expect. So this part is my advice for how you should practice, what problems you should do, etc. It's split into 2 parts, a part for everyone and a part split into sections by rating ranges. Though the part for everyone is more intended for lower ratings anyway. The part for everyone has stuff like how to find problems for practice and what you should do to practice on a specific problem. Stuff that I don't think changes much as you get better or higher in rating, so it'll just be the same for everyone. The rating-based part has stuff like the topics you can benefit from learning, and a bit of strategy advice tailored specifically to your rating. Remember that this advice is strictly geared towards improvement. If you find it more fun to do something I didn't mention or even advised against, do it. It's your game. You can choose how to play it for yourself. But with that said, let's get into the universal advice. So this section is just a bunch of places where you can find problems. All of these are valid choices and they all work for some subset of people on the form. The main idea is the problem should be difficult for you. Just make sure you're getting the mental exercise and let your brain handle the rest. For this, you can find everything listed in the resources section of the description. There's also a question of whether you should do random or topic-based practice, and I'll answer it separately for each rating range, so you can find that in the rating-based part. So the resources are Code Forces, your rating plus like 0 to 500, as in your difficulty, or from a range you know you struggle with. You can use other online judges like CodeChef, AtCoder, Olympiads like Usico, or also ICPC stuff. You can use problems around and above your level on rounds, especially from recent rounds, and also do virtual contests. You can upsolve, especially problems you did badly at during a contest. You can do some topic-wise practice like CSCS, Codeforces tags, Codeforces Edu, etc. Many websites have topic-based tags you can filter by. But also be careful about practicing when you know the tags. It can be like sort of dangerous. You can use structured problem sets like the Mostafa sheet, A20J, books, and mashups, or also problem archives like Usico Training or Temus or regional judges, etc. And you can use different strategies like the strategy of solving some amount of problems from some rating. And now that you've selected some problems to do, what do you do with them? There are many different formats of practice you can do. I don't think it matters so much. Again, the number one thing is that you should be learning. And other than that, do what's most fun for you, or do what you think you'll get the most out of. Probably the most common is just trying a single problem and going for it until you decide to stop. Rinse and repeat. But you can do other things like virtuals or actual contests. There's also mashups, which are just collections of problems. I've actually been thinking of trying the format of creating a mashup of a few very hard problems and giving myself a long time, like a week, to do as many as possible, and like doing that every week or something. I'll let you know how that goes, I guess. There's also some versus options like duels where you pick a problem and race someone else to finish it. There's also lockouts, stuff like that. And there's probably some other strategies out there that can work fine. But yeah, the gist is do what's fun for you. And in terms of time to spend practicing, the vast majority of form responses was in the region between 2 to 4 hours a day. It doesn't take a super intense strategy like spending 6 to 8 hours a day, something like that, and going non-stop grind mode to get to red, and not many people did that. You could do that like how I started competitive programming. You'll probably burn out really quickly, also like how I did. But you don't have to, and you'll be fine just putting in a fair amount of time every day. You don't even have to reach those numbers. I myself was very inconsistent after my first 3 months, and most of the time I wasn't even close to 2 hours a day. Most people also quantified it by time spent instead of the number of problems, which I agree with, because setting a daily problem quota, as I mentioned before, can encourage you to rush and try less on the problems. So just put in some time and do what you can. Now let's continue with how long you should spend trying it, because that tends to be a very common question. The forum highlighted the options of 20 to 45 minutes or 1 to 4 hours. Note that this is after being stuck. So get to the point where you start struggling to find ideas and only then start the timer. And this variety of times also proves the point that there's a lot of variety in working strategies. And also you don't have to take the timing so seriously. You don't have to set an actual timer. That's mostly just overthinking it. The one exception is if you're practicing specifically to be fast enough to solve something in a contest like a virtual, but again, in terms of long-term progress, this is not so important. As I mentioned, I would prefer sticking towards the longer side of time spent on problems. I don't think that you can ever truly be stuck unless it's a conceptual topic-based thing that you're missing. And in that case, some have recommended finding a smart friend and asking them if the problem involves anything you don't know. I would say that this works pretty well, and it's kind of better than just asking directly for help because you're still doing most of the thinking. You're just ruling out something that you don't know. That's also a benefit of using a structured problem set. You get a pretty good guarantee that most of the problems you do are fully solvable with only the knowledge you have. So pick any of those time frames. It doesn't really matter as long as you're really trying and getting that mental exercise. Or you can go even longer. As I've said, it's a viable option to spend even multiple days on single problems, and it's how I practiced when I was starting off, along with a few people from the forum. My personal strategy was mostly just to stop when I got tired of the problem, though I usually have a very high patience for problems, so I would end up trying for days anyway. Now, if you've decided to give up and see the solution, what should you do? There are multiple ways to read an editorial, especially if it has hints. For one, you can just take in the solution at face value all at once. In my opinion, this is almost never useful, only if it involves a topic you're completely unfamiliar with and you're likely not going to get anywhere with the problem. But even then, it can be more worth it to detach yourself from the problem, study the topic, and try it again when you're more experienced. But if you're just seeing the solution for the purposes of wrapping up the problem, why? Unless you have exceptional memory, which is probably not true if you need this video's advice, the point of seeing the solution is to learn how you could have thought of it. If you just want to wrap up the problem, you might as well have not read the editorial at all. So when you read it, think about the motivation. Why does the editorial do this? What did they think about doing that led them to this strategy? Is this some common thought process that I can use in another problem? Sometimes the answer is just that you need to get smarter, as in improve your reasoning and observational skills. In that case, you have to do just that. Practice more. But sometimes you'll find that there are common thought processes that lead you to certain conclusions. People usually call them techniques, but really they're more like mindsets. For example, there's contribution to the sum, dynamic programming, stuff like that. And also think about why your solution ideas didn't work. Why are they different from the editorial? Were you close? And if so, what stopped you from getting the full idea? Editorials with hints are useful in the sense that they make it easier to understand the thought process behind coming up with the solution. But even then, hints are things that you didn't think of. Don't let yourself slack off. You still sometimes have to figure out how you could have thought of the thought process, especially for ad hoc problems. And if there aren't hints, you can try Richto's method of reading the editorial line by line and taking some time to think about each point. It works pretty well. Editorials also highlight stuff that you might not have known about, especially not so common topics that could be useful to know, or like a simpler method that you wouldn't have thought of otherwise. And even if you solve the problem, it could be worth it to see the editorial in search of a simpler idea, or a general idea that could apply to other problems. I usually do this, and it's given me a lot of moments like, wow, that's so much smarter, or holy crap, I'm so far from LGM. And on a similar note, it can be worth discussing with friends or seeing other people's solutions, especially higher rated people, to absorb some new approaches for a problem you tried. For example, my team in high school had a very strong math background, while I didn't. And it's sometimes pretty funny to see how different our solutions were for just a single problem. And the question that's going to come up a lot is, should you do random problems or topic-based practice? And I would say a healthy mix, mostly leaning towards random problems, and the majority of the forum seems to agree. It's probably important to grind each topic a little bit to get familiar with its quirks and how it works, but it's also bad to go into a problem already knowing the main things you're going to have to use. Because during contests, you're going in blind, and you don't know if the topic you're studying will be useful for any of the problems. And similarly, much of your practice should be blind so you can learn when your topic is applicable, and equally importantly, when it's not applicable. Then you'll get better at recognizing that a problem can be solved with a specific topic too. And not understanding when something doesn't work is a huge reason that people get stuck in mental dead ends and spend all their time trying to make one idea work and ending up in wrong answer hell. And this is especially true for stuff like algorithms and data structures. It's less true for like classes of problems like graph problems and string problems because you can usually quickly recognize what class of problem it is. So it's not really important to go in blind for those. But for strategies like greedy and dynamic programming, knowing when it's not going to work is huge. So I propose this. Select most of your problems randomly and take note of your weaknesses. When you know about a particular weakness, you can do a few problems just on that topic or just on that weakness to get more comfortable with it. Then go back to random problems. But if you're still weak on it, you can skew the probabilities so that a problem with that topic has a higher chance of showing up. Then you still get to go in blind, and you still get some variety, but you're going to get a good amount of practice on the topic as well. It's also not strictly important to seek out a list of necessary topics, even though I will give you one anyway. For any topic you don't know if it's important, you'll eventually encounter in a problem. Then you'll know that topic exists, and you'll have evidence that it's important because you already saw it in a problem, at least if it's a recent problem. So you can study it. And especially with recent Code Forces rounds, getting rid of problems where the hardest part is the knowledge factor, meaning there's less hard conceptual stuff and not too many key topics, you will find all the topics you'd absolutely need pretty quickly. That's why it totally works as a practice strategy to just solve random problems and just put time into improving the weaknesses that are highlighted by the problems. So the previous section was general information about practice that would apply to any rating. And this section is advice more specifically geared towards particular rating ranges. Stuff like topics that appear frequently, the rough skill you need to get to the next range, and general strategy stuff like how much you should focus on topic-oriented practice. Here we go! So this is rating 0 to 999, or the starting rating. And maybe negative rating too, but you have to genuinely try to get a negative rating, so probably not. I think my advice in the earlier part of the video is most important to those of you in this range, but it's a lot, so you don't have to take it all in at once. I'm distinguishing this rating from the rest of grade because this is the part where you have to both get used to programming and develop basic solving skills. Later on, you'll improve both of those, but this is the starting point, so I think it's worth highlighting. In this stage, you will roughly learn the fundamentals of your chosen programming language, then immediately throw all that away, because most early problems on Code Forces are about math and basic reasoning with little code to go along with it. On other sites, basic problems are more centered around translating problem statements to code. In any case, you mostly just need to be able to reason about conceptually simple problems. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long, or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. Let's start with topics. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. I also took many of the tags that are mentioned from the forum. I'm also going to try and give some research for each thing mentioned, which you can see in the description, along with the script itself. I'm giving you a list for convenience, but it's probably not going to be exhaustive, and you shouldn't worry so much about it. Again, you will encounter everything you need to know in problems, and then you'll know about it. So most of your problems are going to be math, greedy, constructive, raw implementation, or a combination of those. These are not strictly topics, but they're the types of problems that you're going to encounter the most, so you should be good at them. Here are the relatively vital topics you should be prepared for. It's a short list. You have brute force / searching. You have sorting, but mostly you just need to know how to use your library's function. You have strings, and there's not much to learn for this, but you should be familiar with what they are. You have number theory, specifically floor / ceiling, and modulo, those functions. As a tag, in Code Forces there's usually lumped under math, but I think these are specifically number theory. And you should also start to understand how time complexity works. Even the easiest problems can have a high input constraints, and it's important to know what will run under the time limit and what won't. And here are some topics that can show up sometimes and can help with a select few problems, but aren't super common at this level. There's different aspects of number theory, specifically divisors and factorization algorithms. There's STL / your language's library, and you mostly just have to know what it's capable of. There's binary search, 2 pointers, and binary or bitwise stuff. And a lot of people have said stuff like graphs and dynamic programming for this level, but the script disagrees. Here's the top 10 tags that were found at this level. DP is less than 10% of all the problems, and graphs aren't even close. And most of these are technicalities, like there exists a solution that uses DP, but the intended solution is usually easier and simpler. So really, you're getting ahead of yourself by trying this stuff. Learn basic reasoning, and everything else will come much easier afterwards. To get through this range, people have generally said you need to solve A and B relatively smoothly in Div 2s. That means not slowly and with not many mistakes. For Div 3s, you probably need another problem. I wanted to answer this in terms of problem ratings too, but few people responded like that, so sorry. And feel free to focus on this as a goal, but first remember that every contest is different, so you shouldn't be too rigid about it. And also, if your plan is long-term improvement to a higher rating than 1000, don't worry about it too much. Get better and the rating will follow naturally. The general strategy for this rating range is simple. Just work on improving your reasoning, and that means practicing on random problems. You have very little conceptual stuff to learn because most of what you should be doing is just getting familiar with the different types of problems, like math and constructives. You don't need to seek out topics. If something is frequently a weakness in your practice, you'll be able to notice it and work on that thing especially. So that's it. Pick out random problems and do them. If you notice any glaring weaknesses, spend some time getting comfortable with them, and then go back to random problems. Rinse and repeat. At rating 1000 to 1199, you should have a decent command of your programming language, and you're mostly working on building up your reasoning skills more. Maybe you're starting to dabble more in some of the more common tricks such as binary search, but you're probably still not seeing too much of it. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long, or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. Let's start with topics. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. I also took many of the tags that are mentioned from the forum. I'm also going to try and give some research for each thing mentioned, which you can see in the description, along with the script itself. I'm giving you a list for convenience, but it's probably not going to be exhaustive, and you shouldn't worry so much about it. Again, you will encounter everything you need to know in problems, and then you'll know about it. So most of your problems are going to be math, greedy, constructive, raw implementation, or a combination of those. These are not strictly topics, but they're the types of problems that you're going to encounter the most, so you should be good at them. Here are the relatively vital topics you should be prepared for. If you saw the last section, you'll see that I mostly just moved some of the optional topics into the important category. There's brute force and searching, and there's sorting, but you mostly just need to know how to use your library's function. There's strings, still not much to learn for this, but you should be familiar with what they are. There's number theory, specifically divisors, factorization algorithms, floor/ceiling functions, and modulo. There's STL, or your language's library, and you should mostly just know what it's capable of. And you should definitely understand time complexity by now. You should have a decent sense of whether a program will be acceptable or way too slow. And here are some that can show up sometimes and can help with a select few problems but aren't too common at this level. There's binary search, 2 pointers, binary or bitwise stuff, dynamic programming, basic combinatorics, and basic range queries, stuff like prefix sums. To get through this range, people have generally said you need to solve the first 2 problems fast or the first 3 problems in a Div 2. For Div 3s, you probably need another problem. I wanted to answer this in terms of problem ratings too, but few people responded like that, so sorry. And feel free to focus on this as a goal. But first, remember that every contest is different, so you shouldn't be too rigid about it. And also, if your plan is long-term improvement to a higher rating than 1200, don't worry about it too much. Get better, and the rating will follow naturally. The general strategy for this rating range is simple, and the same as the last rating range. Just work on improving your reasoning. And that means practicing on random problems. You have very little conceptual stuff to learn because most of what you should just be doing is just getting familiar with the different types of problems, like math and constructives. You don't need to seek out topics. If something is frequently a weakness in your practice, you'll be able to notice it and work on that thing especially. Even the topics I mentioned in the topics section could be a stretch. Reasoning will get you very far, so your main goal should just be to get smarter. So that's it. Pick out random problems and do them. If you notice any glaring weaknesses, spend some time getting comfortable with it, then go back to random problems. Rinse and repeat. At rating 1200 to 1399, you're probably pretty solid on the programming side. Most of the coding difficulty should now come from implementation, which is mostly about translating your ideas to the actual tangible matter that is code, and getting all the details right and stuff. Your knowledge base will start to become a bit more important at this point, and you'll see problems start to require more than just reasoning. But a lot of it is still reasoning. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long, or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. Let's start with topics. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. I also took many of the tags that are mentioned from the forum. I'm also going to try and give some research for each thing mentioned, which you can see in the description, along with the script itself. I'm giving you a list for convenience, but it's probably not going to be exhaustive, and you shouldn't worry so much about it. Again, you will encounter everything you need to know in problems, and then you'll know about it. So most of your problems are going to be math, greedy, constructive, raw implementation, or a combination of those. These are not strictly topics, but they're the types of problems that you're going to encounter the most, so you should be good at them. Here are the relatively vital topics you should be prepared for. For the sake of brevity, I'll take out the topics from previous sections, like previous rating ranges, that you should already have a very high chance of being familiar with. So there's number theory, specifically divisors, factorization algorithms, modulo and modular arithmetic, floor/ceiling functions, GCD and LCM, the prime factor representation of a number, and like fundamental theorem of arithmetic stuff. There's STL/your languages library. You mostly only need the essentials like sorting and a couple of data structures. I'll link a video on it. But also be familiar with what it's capable of. There's binary search, becomes important. There's two pointers, which is pretty rare, but it's somewhat related to binary search, so they can be good to learn together. There's basic combinatorics, like the choose function stuff. There's basic range queries, namely prefix sums, which you aren't going to see that often, but it's good to understand the mindset of what prefix sums are trying to do, because it's kind of a good way of thinking. There's recursion as a prerequisite to dynamic programming. And this is a tough one, because you have to really understand what you're doing to be able to reason and solve new problems with it. Like I said before, dynamic programming is a mindset. It will take a while, and you will almost definitely struggle in the beginning, but it's also absolutely necessary in the long run. And here are some topics that can show up sometimes. It can help with a select few problems, but aren't super common at this level. There's binary and bitwise stuff, which is rather rare, and it seems to always be rare, but it's helpful to have some knowledge in advance for the problems that you will encounter. There's graphs and trees, which is, yes, in the optional section. The script still places it at less than 10% of recent problems in this level. The main thing to learn here are basic definitions and searches like BFS and DFS. The rest is unnecessary for now, and most of the difficulty still comes from reasoning anyway. As an extension to graphs, there's DSU, UFDS, whatever you call it. This is definitely not necessary, but it's a powerful tool that can basically cheese a bunch of graph problems. There's segment trees. You probably won't see this much, especially in contests, but much like DSU, it's super powerful and can destroy much data structure problems, but don't make it a priority. And finally, there's string algorithms, namely hashing. You can do basically anything you would need for strings with binary search and hashing for logarithmic comparison, but it's not that common, so it'll be optional. And for reference, here's the top 10 tags from the script. To get through this range, people have generally said you need to solve the first 3 problems in a Div 2, somewhat quickly but not necessarily super fast. Sometimes you can get away with 2 problems if it's a hard contest and you're very fast, but you mostly need 3. For Div 3s, you probably need another problem. I want to answer this in terms of problem ratings too, but a few people responded like that, so sorry. And feel free to focus on this as a goal. But first, remember that every contest is different, so you shouldn't be too rigid about it. And also, if your plan is long-term improvement to a higher rating than 1400, don't worry about it too much. Get better and the rating will follow naturally. In this range, topics are a bit important, but only the very general ones like binary search and the number theory stuff. Since there will start to be a lot of different types of problems, you should be taking note of your weaknesses. And when you find one, practice it more than usual to get more comfortable with it. It can also be worth it to try and notice patterns in the issues that you have with problems. For example, did you not solve it because you didn't know a topic? Does that topic show up a lot? Or is it because you just didn't think of it? Or you missed an observation? Or did you overcomplicate it? And do these mistakes repeat themselves? Knowing your weaknesses is the first step in correcting them. But other than that, the classic practice strategy of random problems will work, I promise. Improving your reasoning just helps with everything. At rating 1400 to 1599, you've done it. You've made it past the hardest part. You've figured out a practice strategy that has worked for you well enough to enable you to consistently solve multiple problems. So stick with it. But this video is mostly here to help you tweak your strategy or figure out what you're up against. I think you can safely ignore my advice now, but feel free to listen to it anyway if you want. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long, or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. Let's start with topics. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. I also took many of the tags that are mentioned from the forum. I'm also going to try and give some research for each thing mentioned, which you can see in the description, along with the script itself. I'm giving you a list for convenience, but it's probably not going to be exhaustive, and you shouldn't worry so much about it. Again, you will encounter everything you need to know in problems, and then you'll know about it. Here are the relatively vital topics you should be prepared for. For the sake of brevity, I'll take out the topics from previous sections that you should have a very high chance of being familiar with already. There's number theory, like factorization algorithms, GCD and LCM, modular arithmetic, and the prime factor representation of a number, like fundamental theorem of arithmetic stuff. There's STL in your language's library. You must only need the essentials like sorting and a couple of data structures, and I'll link a video on it. There's binary search and 2 pointers. There's basic combinatorics like the choose function stuff. There's basic range queries like prefix sums. It's not going to be that common, but it's good to understand the mindset of what prefix sums are trying to do, because it helps. It's a good way of thinking. There's recursion and dynamic programming. Just get better at this over time. You might eventually need tree DP too, but it's not particularly different from normally DP. Just a bit weirder, so I would lump it in the same topic. There's graphs and trees. They're rare according to the script, but you'll encounter them more often now, so I guess it's worth being prepared for. You really only need the basics like BFS, DFS, and the terminology. At this point, you're probably capable of intuiting to some degree whether a solution should be correct or not. And while this intuition is good, it's also important, mostly during practice, to spend time trying to fully prove your solutions to be correct. This can help you further strengthen that intuition and be more confident in your solutions. And beyond all that, you'll see a lot of constructive problems. Get good practice on those. And here are some topics that can show up sometimes that can help with a select few problems but aren't super common at this level. There are techniques for combinatorics, like inclusion-exclusion and contribution to the sum. Along with combinatorics, you might rarely encounter a problem on probability or expected value. There's DSU, which is very rare but can be useful for graphs. You rarely need more advanced graph algorithms like shortest path or minimum spanning tree, but it could be helpful in the niche situation. Minimum spanning tree also comes free with DSU. There are segment trees, also rare but very useful for overcoding data structure problems. Family trees are very optional because they only give like a speed boost. You can also learn string algorithms like hashing, but strings are uncommon anyway. And you might also see game theory start to become relevant. I would recommend just the basics and also learn how to write like a brute force and C patterns. And here are the top 10 tags from the script for reference. To get through this range, people have generally said you need to solve the first 3 problems in a Div 2 with decent speed and consistently. For Div 3s, you'll hit a phenomenon in the rating system where you usually gain more rating in Div 3s than others. This is because you're going to be near the top of the scoreboard and the rating system heavily favors people near the top. So you'll probably be overrated if you rocket into expert with a Div 3. Don't let it get to your head or be super discouraged if you fall hard afterwards. I wanted to answer this in terms of problem ratings too, but few people responded like that, so sorry. And feel free to focus on this as a goal. But first, remember that every contest is different, so you shouldn't be too rigid about it. Also, if your plan is long-term improvement to a higher rating than 1600, don't worry about it too much. Get better and the rating will follow naturally. In this range, topics become decently important. Mostly the very general ones like binary search and DP-like stuff, but you might encounter some rare stuff too. Most problems will use only the common topics, which tend to be the ones on the given topic list, and you will notice diminishing returns from learning more and more rare topics. Especially with the recent style in code forces, I wouldn't worry about anything that's not common. Since there will start to be a lot of different types of problems, you should be taking note of your weaknesses, and when you find one, practice it more than usual to get more comfortable with it. It can also be worth it to try to notice patterns in the issues that you have with problems. For example, did you not solve it because you didn't know a topic? Does a topic show up a lot? Or is it because you didn't think of it, or you missed an observation, or overcomplicated it? And do these mistakes repeat themselves? Knowing your weaknesses is the first step in correcting them. But other than that, the classic practice strategy of random problems will work, I promise. Or you could just keep doing what's been working for you. You have a better sense of what will work for your style than I do. At 1600 to 1899, you'll totally do fine without this video. But I'll give it to you anyway. But just to point it out, to get to this rating, you have somehow found a functional strategy that worked to get you past the beginning levels. Continue with it. Feel free to learn from this advice, but you don't have to overthink it. Also note that you probably got more rating from Div 3s than Div 2s because the rating system favors those near the top. Now that you can't do this anymore, you may feel yourself progressing slower, but it could just be that you were given too much rating in the first place. You'll encounter something similar when you start doing Div 1s past 1900. Okay, first, here's the list of people that I want to thank for filling out the form. either because it'll take too long or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. Let's start with topics. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. I also took many of the tags that are mentioned from the forum. I'm also going to try and give some research for each thing mentioned, which you can see in the description, along with the script itself. So here are the relatively vital topics that you should probably know to be able to continue. And even at this point, you don't really need the niche stuff. Even with just the basics and most common stuff, you'll be fine. DP is important for sure. It's become quite common at this level according to the script. It's very hard to come with novel forms of niche DP like bitmask the optimizations, so you probably won't see them in newer contests. And same for graphs and trees, you will likely see them decently often. You'll need traversals and likely topological sort for directed graphs. The rest are extra, the shortest paths and minimum spanning trees are potentially useful. There tends to be some number theory too, though you typically won't need more than the basics like factorization algorithms, modular arithmetic, and the prime factor representation of a number like fundamental theorem of arithmetic stuff. You should know your combinatorics, at least the very basics, and maybe stuff like inclusion exclusion too. Also probability and expected value. Know your bitwise stuff. Those problems can be a pain if you haven't done much practice on it. You should know some data structures like segment tree for range queries and most of what your standard template library is capable of, STL. Know the basics of game theory because you'll be totally lost if you don't, and it'll come up sometimes, though usually rarely. You should be somewhat capable of proving a solution, particularly ones like greedy problems, though it's not totally necessary. You probably have some intuition about whether certain solutions are correct or not, and practicing with proving will help make that intuition stronger as you pick up on better ways to prove things. And don't forget about constructives. There's little to learn about them, but you need the practice to get good at the style. And if I missed anything on that list, it's either common enough that you already know it, or niche enough that you probably don't need to. And here are the top 10 tags from the script for reference. To get through this range, people have generally said you need to solve the first 4 problems in Div 2s consistently. Some people said you need to do it quickly, others didn't. I wouldn't worry about it too much since every contest is different. And I wanted to answer this in terms of problem ratings too, but a few people responded like that, so sorry. And feel free to focus on this as a goal. But if your plan is long-term improvement to a higher rating than 1900, don't worry about it too much. Get better and the rating will follow naturally. As for an overall strategy, I would say just keep doing what's been working for you. Like the past rating ranges, you will do fine if you only know the most common topics. Don't overthink it. But I can give you the spiel on mistakes too. It can be worth it to try to notice patterns in the issues that you have with problems. For example, did you not solve it because you didn't know a topic? Does that topic show up a lot? Or is it because you didn't think of it, or missed an observation, or overcomplicated it? And do these mistakes repeat themselves? Knowing your weaknesses is the first step in correcting them. This helps a lot with consistency, which becomes more and more important the higher up you get in rating. So, 1900 to 2099. Welcome to Div 1. At this point, you definitely know what you're doing in terms of practice already. Frankly, I don't know why you're here. The roadmap to red part was mostly just to make the clickbait more effective. The stuff holding you back is probably just your raw solving ability and or maybe your overall knowledge base. It could also be something psychological, like in my case. And whatever it is, here's what the forums and or script said about how to get good. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. As for topics, I'm just going to use the same clip for this part of the last 2 ranges since the message is the exact same. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. So I'll show you that. But really, you're free to do whatever you've been doing. Trust yourself. For the higher rated people, this video is mostly just a pep talk that you already have a strategy and you'll be fine. Especially because there's a huge difference between the styles of old and new problems, where old problems were much more based on knowing things and new problems are much more based on reasoning and novelty ideas. You can get away with knowing the basics, even all the way to red. Basically every red response on the forum agreed with that, and many others as well. The strategy of learning the basics and learning the less common topics only if you see them often enough in problems you encounter will work fine. And you've made it this far, I'm sure whatever you're doing works fine as well. I myself find that I have a much weaker knowledge base than many 2400s and even 2100s sometimes. So learn what you're interested in, but you don't have to seek out niche topics. I understand the fear of hearing about something, not learning it, and having that be on a problem in an upcoming contest. Trust me, I really understand that fear. But it happens so rarely, if at all. It's not worth being concerned about. And again, rating changes are temporary, so even if you miss something due to not knowing something, it'll be offset later on. But if you really want a curated list, you can check out the section for 1600 to 1899. I don't really want to re-record it. Anyway, I'll also show you the top 25 tags from the script, which is almost all of them. To get through this range, people have generally said you need to solve the first 4 problems in Div 2s consistently, and sometimes the 5th. To survive in Div 1, you usually need at least 2 problems, and since the problems aren't as easy, speed is less relevant, so focus on pushing toward that next problem. For Div 2s, you'll hit a phenomenon in the rating system where you'll usually gain more rating in Div 2s in other contests. And this is because you're going to be near the top of the scoreboard, and the rating system heavily favors people near the top. So you'll probably be overrated if you rocket into Master with a Div 2. Don't let it get to your head or be super discouraged if you fall hard afterwards. And related to this, people have also recommended not doing Div 1s, but it's up to you. Remember that temporary rating changes are temporary. And feel free to focus on this as a goal. But you already know what motivates you, so also just do what you want. And as for an overall strategy, I would say just keep doing what's been working for you. But I can give you the spiel on mistakes too. It can also be worth it to try to notice patterns in the issues that you have with problems. For example, did you not solve it because you didn't know a topic? Does that topic show up a lot? Or is it because you didn't think of it, or missed an observation, or overcomplicated it? And do these mistakes repeat themselves? Knowing your weaknesses is the first step in correcting them. And this helps a lot with consistency, which becomes more and more important the higher up you get in rating. So, 2100 to 2399. If red is your goal, this is the final stretch. At this point, you definitely know what you're doing in terms of practice already. Frankly, I don't know why you're here. The roadmap to red part was mostly just to make the clickbait more effective. And if you're angry about my not distinguishing International Master, sorry, that would just be pointless though. Neither 2100s nor 2300s need this video. The stuff holding you back is probably just your raw solving ability and or maybe your overall knowledge base. Could also be something psychological, like in my case. And you've also reached the point where you can't do Div 2s anymore. You've most likely gotten better rating changes from them because the rating system favors those near the top in the contest. So Div 1s may be discouraging and you may feel like you're stagnating, but it's really that the Div 2s probably gave you too much rating in the first place. Anyway, here's what the forum and or script said about how to get good. Okay, first, here's the list of people that I want to thank for filling out the form. Either because it'll take too long or out of fairness for the other sections that would have taken too long. I won't read out the names, but seriously, huge thanks to everyone who did the form. And also a special thanks to Kevin XU for keeping me sane the last month or so, and also actually reminding me to add this section. God, that would have sucked if I had forgotten. But anyway, now for the actual advice. As for topics, I'm just going to use the same clip for this part of the last 2 ranges since the message is the exact same. I wrote a script to find the most common tags for a range of difficulties, specifically for recent problems to keep it relevant. So I'll show you that. But really, you're free to do whatever you've been doing. Trust yourself. For the higher rated people, this video is mostly just a pep talk that you already have a strategy and you'll be fine. Especially because there's a huge difference between the styles of old and new problems, where old problems were much more based on knowing things and new problems are much more based on reasoning and novelty ideas. You can get away with knowing the basics, even all the way to red. Basically every red response on the forum agreed with that, and many others as well. The strategy of learning the basics and learning the less common topics only if you see them often enough in problems you encounter will work fine. And you've made it this far, I'm sure whatever you're doing works fine as well. I myself find that I have a much weaker knowledge base than many 2400s and even 2100s sometimes. So learn what you're interested in, but you don't have to seek out niche topics. I understand the fear of hearing about something, not learning it, and having that be on a problem in an upcoming contest. Trust me, I really understand that fear. But it happens so rarely, if at all. It's not worth being concerned about. And again, rating changes are temporary, so even if you miss something due to not knowing something, it'll be offset later on. But if you really want a curated list, you can check out the section for 1600 to 1899. I don't really want to re-record it. Anyway, I'll also show you the top 25 tags from the script, which is almost all of them. To get through this range, people have generally said you need to solve at least 2 problems in Div 1s and usually 3. Another bit of advice from the forum is that consistency is really important at this range. It's not strictly necessary, but it's better because it's hard to get 2600 level performances without solving like the 4th problem most of the time, and 2400 level performances happening sometimes isn't enough. So if you get your performance consistently at your full potential, you will have a much easier time. And I noticed this myself too. When I worked on my sleep and some psychological stuff, I shot from mid 2200s to Grandmaster and even IGM, and also stayed there. My rating graph was recently very not volatile, meaning the consistency was good. Feel free to focus on this as a goal, but you already know what motivates you, so just also do what you want. And as for an overall strategy, I would say just keep doing what's been working for you. But I can give you the spiel on mistakes too. It can also be worth it to try to notice patterns in the issues that you have with problems. For example, did you not solve it because you didn't know a topic? Does that topic show up a lot? Or is it because you didn't think of it, or missed an observation, or overcomplicated it? And do these mistakes repeat themselves? Knowing your weaknesses is the first step in correcting them. And this helps a lot with consistency, which becomes more and more important the higher up you get in rating. You know, I could double down and pretend that the long wait for this video was just a trick to force you to have to live without strict guidance, and maybe figure something out for yourself, which is exactly the message I wanted to send, but I won't. This video took way longer than it should have, and I'm sorry. I explained all that has happened in my previous video, so watch that if you missed it. To those of you who waited for this video and stuck around with the hype, thank you. To everyone else, thank you as well. I hope you took what I was trying to say seriously enough to learn something new from it. There's definitely this stigma around YouTubers of making content that's mostly useless, such as roadmaps, for the sake of attracting many viewers who eat this stuff up, because the concept of a roadmap is actually pretty cool if it actually works. But as a YouTuber who is about to post a roadmap, obviously this stigma doesn't exactly help me. I've gotten quite a few messages, especially from high-rated people, about being a sellout or succumbing to the views and stuff like that. And I get it. In the literal sense, it's true. I am posting a roadmap with the intention of it getting a lot of views. But the point of the video isn't the roadmap. It's the message that this type of content isn't really going to be helpful. It's like a Trojan horse. You expect a guide, and instead you get smacked in the face with reality. And the point is also the part in the advice section about how many people aren't really learning from their practice. I hope at least the people who've made sarcastic comments can understand that. I don't want to reinforce the idea that you can blindly follow a roadmap and have your dreams come true. I want to destroy it. But I also don't want the entire video to be a lie, so I have included the roadmap part anyway for the sake of completeness, and because that information can still be useful. And I market it as a roadmap because the people I want to send the message to are the people who would click on a video like this. And I want to ask, where do you, like just anyone watching you, think this frequent occurrence of blind faith in a YouTuber or guide comes from? I personally think it comes from education. I've heard a lot of things about schools teaching people to follow like exactly a given set of rules for solving problems and just doing nothing else. That's all. Just memorize some steps and apply them to pass some tests. From the moment you enter school, that's all you do. So obviously you're going to struggle to think outside the box if the entirety of your childhood has been wasted on this kind of garbage. And obviously it's not necessarily 100% that, but any amount of it tends to suck for actual learning purposes. And naturally, people will look for the same thing in competitive programming. A set of steps they can follow. A roadmap. I'm not saying this applies to you, as in you who's watching this video right now, because obviously I don't know. But I want you to reflect on your life and ask yourself if it does apply to you. If it doesn't, that's fine. You can click off the video now, there's nothing more for you. Or don't, it's up to you. But if it does apply to you, know that problem solving just doesn't work that way. If every problem could be solved by just following a set of instructions for it, everyone would be a Grandmaster. You just have to be able to think outside the box. You have to be able to try new ideas when everything you've thought of hasn't worked so far. If the muscle that lets you do that has atrophied or wasted away because school hasn't allowed you to use it much in your life, it's going to be hard, but you just won't get anywhere if you don't practice thinking of new ideas. And again, how do you practice this? Immerse yourself into problems, sometimes for hours or days if it's necessary. You will eventually get random thoughts or ideas that you may have never seen before. Take them and run with them. See how far they go. They may turn into a solution or they may not. Either way, that's a new idea you came up with. Keep doing it until it works. Eventually, you'll get better at coming up with ideas. A few more of your ideas will work on the first try. You'll be able to recognize ideas and new problems that you saw or came up with in old ones. You'll unlock that magic intuition that most skilled people have but can't really explain, and it will get stronger and stronger over time. And when you experience that, that's when you know your practice has been paying off. And it will pay off. Get your rhythm, get a practice strategy that works for you, and you'll be able to progress at a good pace. I truly believe that the only difference between someone who's proven to know what they're doing, like many stable scions, and a Grandmaster, is time. Keep knowing what you're doing, and put the time in, and you'll get far. I hope this has helped. That's all. Goodbye.